Hallo, Hilderduut 35 hier. Vandaag ga ik jullie leren hoe je een FLL-robot kan uitlijnen zodat hij mooi recht op de lijn staat van je challenge map. Maar eerst dit. Zo, nu even snel overlopen hoe de robot zichzelf kan uitlijnen. De robot zal rechtdoor rijden tot hij de zwarte lijn ziet. Dan denk je, geweldig, we zijn er. Echter, het is niet zeker dat hij wel mooi recht op de lijn staat. Want zo ziet hij de zwarte lijn en zo ziet hij de zwarte lijn. En we willen juist dat hij loodrecht op de zwarte lijn staat. Op deze manier werken je programma's altijd. Werkt het nu? Wel, als hij die zwarte lijn vindt, gaat hij met één wiel over de lijn rijden tot hij de witte rand ziet. Hij zet dan zijn omwentelingsteller op 0 en rijdt achteruit tot hij het andere witte stuk ziet. De robot kent dan de hoek die hij net gereden heeft en deelt hem door 2, zodanig dat hij mooi terug op de zwarte lijn komt als hij dit vooruit rijdt. Zo, daarna doet hij het met de andere kant. Eerst naar voor, tot aan het witte deel, en de rotatiemeter reset dan naar achter, tot hij opnieuw het witte deel tegenkomt. En die afstand delen door 2 en naar voren rijden. En je komt terug op het zwarte deel. Ik ga je dadelijk stap voor stap uitleggen hoe je dit allemaal kan programmeren. Maar eerst moet je weten hoe je sensoren en je motoren zijn aangesloten op de blok. Deze kleursensor zit op poort 1 en bestuurt motor B. En deze kleursensor zit op poort 2 en bestuurt motor C. Wat we ook nog moeten weten zijn welke lichtwaarden de sensoren meten als ze over zwart of over wit rijden. Dit moet je zelf doen. Ga hiervoor op je blok naar het menuutje Port View. En dan zal je zien dat op de zwarte lijn hij 4 geeft en op het wit geeft hij 87. Die waarden gaan we gebruiken in het programma, maar zijn waarschijnlijk voor jou anders.
Alright, so now I'm at my computer, and you'll notice in the bottom left, I wrote some notes for myself for future reference that are going to be helpful. These are specific to my robot, you're going to need to measure them yourself, but I just put these here for this example. Now I'm sorry if the resolution comes out bad, I'm really going to need to find another screencast or video editing software. So none of this will be here next time. None of this will be a problem. Okay. So now the first thing you're going to do is drag out a move tank my block and then insert that into a loop my block. And now the purpose of this is to make the robot drive forward until it sees the black line. So we're going to set this for color sensor, then reflected light intensity. And now since this is until we see the black line and the black line is 4% light, we're going to set this to less than or equal to. And then we're going to set this to something like 8, because you don't want it exactly 4, because you don't always get exactly 4, so you want it to give a little bit of breathing room. And this is going to be port 1 color sensor. It really doesn't matter for this, because it's an either or kind of thing. Anyway, so, and then you're going to turn your motor on, and I'm going to give it negative power, because negative means forward on my robot. And I'm going to give it about, let's say, 40%, because the slower you go, the more accurate your driving will be. So now it goes forward until it sees the black line. Now we're going to tell it to stop on that black line. So we're going to just turn motors B and C off. Now the next thing we want it to do is align each wheel into the middle of the line separately. So what we're going to do is we're going to drag out another loop block here, and I'm just going to put it like this just for separation's sake to make it easier for you guys to follow where I'm going. Then you're going to take a large motor block and you're going to set this for motor B. We're going to center motor B first. So we're going to set this to negative 20% power, because we're going forward until it sees the white line. It's just going to be turned on. And then we're going to set this to color sensor, reflected light intensity, and then you're going to set this to greater than or equal to 85%, because 87% was what we measured the white line to be. So then, after that, you're going to put another large motor block, then you're going to hit off, because after it sees the first edge of the white line, it's going to stop. Then you're going to go into the sensor category. Drag out a motor rotation block. Set it for motor B. I forgot to set this for motor B. So everything right now should be set to motor B. And then you're going to hit reset. Also, the one thing I forgot is this is going to be color sensor 1. Because remember, color sensor 1 is going to control motor B. Color sensor 2 is for motor C. So now what we want it to do is we want that same wheel to go backward until it sees the other white edge of the line. So what we're going to do is take out another loop block. Then we're going to go into our actions here. We're going to take out another large motor block, set it for B. Now we want it to go forward with 20% power until, so we're just forward 20% power, just turn it on. And now go in here to your loop block, set it for color sensor, then reflected light intensity, and then again, we're going to set it to case 3, which is greater than or equal to, and you're going to set your value to 85. Then, one thing is that you're going to want to add a little wait here, and the reason for this, a little time wait, so we're going to set it to like 0.2 seconds, and the reason for this is that it's already starting on a white line, and if you just turn it on to look for the white line right away, it's just going to see the white line that it's already on. So what you want it to do is you want it to give it a head start to get over the black line before it starts looking for the other white line. So I hope that makes sense. Alright, so anyway, it goes backward until it sees the other white line. Then you want it to go back, then you're going to go back into the actions. Then you're going to tell it to stop motor B. Now here's the really important part. Here's how we're going to get it to center this wheel on the line. We're going to go into sensor. You're going to take out a motor rotation block. Make sure it's set to B. Oh, one thing I forgot to set this color sensor to 1. So we're going to set this motor rotation sensor to B. Then you're going to take out a math block right here. You're going to set it to divide. You're going to take this data wire and plug that in for your A value, and then your B value is going to be 2. So now what this is doing is it's taking the motor rotation that it measured off of B, divided by 2, and now that's going to be the number of degrees that motor B is going to drive in the forward direction. And this is how it's going to center itself. So now we're going to take the motor B block, we're going to put it on for degrees at negative 20% power, because remember a slower power will be the most accurate, but if you feel that you need to go a little faster, then by all means do it. Alright, so now what we've done is we've told motor B to drive forward until it sees the white line, then reset its motor degree counter, then go backward until it sees the white line, and measure that distance, then divide it by 2, and it should be exactly in the middle of the black line. So now that we did that for motor B, now we need to do the same thing to motor C. We need to center the right wheel onto the line. So what we're going to do is we're going to do the same exact thing as we did last time, except you're going to change all of your motors and sensors. Your motor is going to change to C, and then your sensor is going to change to number 2. So I'm going to go fast because you just saw me explain how to do it. So drag out a loop block, now a large motor block, set it for motor C, negative 20% power, and it's just going to be turned on until the reflected light intensity is less than or equal to, greater than or equal to 85%. Then you're going to drag out a motor rotation sensor block for motor C, and you're going to just have it reset. Make sure that your color sensor is set to port 2, and you also want to tell your motor C to stop moving when it sees this white line. So now we're just going to turn it off. So now the next thing to do is to tell the motor to go backward until it sees the white line again. So we're going to drag out a loop block like this. We're going to take a large motor block and we're going to set it to C, it's just going to be turned on, and make sure you're going in the reverse direction. So that, for me, that's a positive power, and I'm going to set that to 20. Now we're going to take a short wait block of about 0.2 seconds, so the motor has time to get over the black line. You're going to change the loop status to reflected light intensity, and that's going to change to greater than or equal to 85%. Always remember to switch your sensor to the proper port. In this case it's port 2. And so now we're going to go back to our actions. We're going to tell this motor C to stop on the white line. So you're going to shut it off. And then you're going to take a motor rotation, set it for C. Then you're going to drag out a math block, set it for division. It's going to divide by 2. Then you're going to take this data wire and you're going to drag it into as your A value, just like that. Now the last thing you're going to do is give motor C the final action to move into the center. So C, and now you're going to drag out this equals, well not yet, you're going to set it to degrees, and now you're going to drag this out as the number of degrees, and make sure it's in the forward direction, so that, for me, that's a negative. And then, if you want, you can drag out a move tank my block, and just tell all of the motors to turn off, so they stop. And so, that should be the program. Now let's go download it on our robot, and just test it out. So I've downloaded my program onto the robot, and let's test our work. Now we see that the robot is perpendicular with the line, and this will make your programs very consistent. Disclaimer, however, is that if you start approaching the line at such a severe angle like this, it will not be able to line up to the line. So that concludes my lesson today. Thank you for watching this all the way through. I really appreciate it. If you found this video helpful, please like it. And if you want more, subscribe to my channel. Next week's video is going to be all about how to build your ideal FLL robot. So as a reward for watching this all the way through, here's a little blooper.
Now I'm going to show you Murray!